2016 AMC12A Question 15. Circles with centers P, Q, and R, having radii 1, 2, and 3 respectively, lie on the same line L and are tangent to L at P', Q', and R' respectively, with Q' between P' and R'. The circle with center Q is externally tangent to each of the other two circles. What is the area of the triangle PQR? Okay, so what I have here is I have a line, and I have three circles. I have circle centered at P, circle centered at Q, and a circle centered at R. And the first time I looked at this, I thought, it looks like these might be collinear with an area, not even a triangle, like an area of 0, but that doesn't actually end up being the case. So what happens is this. So I can sort of try to draw this triangle, and I get a shape like this, and try and figure out, okay, how can I deal with this? Well, it's actually not too bad. So let me put this. This is 1. Those radii are 2. And this radius is 3. What I can end up doing is the following. I can make a trapezoid here, and I can make a second trapezoid here, and I can make a third trapezoid going from the first triangle all the way to the last triangle. First circle to the last circle, and if I add the first two trapezoid areas and subtract the third, I'll either get my area straight away, or if it so happens that this point is below the line, I'll get the negative, and I'll notice it's negative and fix it. So, getting into this, let's look at the green trapezoid first. Sorry, not green, that was blue when I first did it. Let me do blue. So, blue trapezoid first, this one. Okay, so I know this is 1 and this is 2. I need to basically know the height to get this, and here's how I do that. I'll make a right triangle here. This right triangle, the hypotenuse is 1 plus 2, which is 3, and this leg here is 1 because this length is 1. 1 plus another 1 is 2. Using the Pythagorean theorem, I have this squared plus this squared equals that squared. So let's say, sure, I'll call it x. X squared plus 1 squared equals 3 squared. Square them all. I get x squared plus 1 equals 9. Subtract 1. X squared equals 8. And so x equals, taking the square root, 2 root 2. And that's going to be that height right there, and I can do the area formula, so I'll call that area 1, will equal base 1 plus base 2, so 1 plus 2 divided by 2 times the height, which is 2 root 2. I can cancel out these 2's. 1 plus 2 is 3, so I get 3 root 2. Second area works very similarly. So I have 2 and 3. I need to find this length to get the height of the trapezoid. And same idea, I'll get a triangle that has a hypotenuse of 5 and a leg of 1. I'll call this y, so I get y squared plus 1 squared equals 5 squared. 1 squared is 1, 5 squared is 25. Subtract the 1, I'll get y equals root 24, which is the same thing as 2 root 6. And so the area of this green trapezoid is now going to be, I'll call it area 2, base 1 plus base 2, and our bases are these vertical measures, divided by 2 times the height, which is 2 root 6. And similarly, the 2's cancel. 2 plus 3 is 5, so I get 5 root 6. Finally, I can go after this yellow large trapezoid. I don't need to do any more right triangles because that's all done. So what I get is base 1 is 1, so I'll call this A3. base 2 is 3, divided by 2, times, and the height is just the sum of these, 2 root 2 plus 2 root 6. 1 plus 3 is 4, divided by 2 is 2, distributed through gives me 4 root 2 plus 4 root 6. That's the yellow. And so, to finish this off, I'll take area 1 plus area 2 minus area 3. At least that's what my diagram looks like. I'll check to make sure that it is positive, because perhaps these are actually below the yellow line up there. And that's going to give me the area of the triangle left over, this triangle here. So area 1 was 3 root 2. Area 2 is 5 root 6. Area 3 is 4 root 2 plus 4 root 6. And subtracting it through, I will end up getting negative root 2 plus root 6, which is clearly positive. Root 6 is bigger than root 2. So the answer is D. Feel free to comment below with any questions.